Okay, I think you can all see the code. So you are talking about overloading the prefix and the postfix operators. So this is where we got stuck. So overloading unity operators, the prefix, the pre-increment and the post or p-decrement and the post-decrement. And what we found is because the operators are same in both the cases, it is double minus. But if you place it as a prefix, it will be pre-increment. If you place it as a post in the postfix form, it will act as a post-decrement. Now, when you convert it to a operator function, it still names as operator minus minus. And in fact, the number of arguments are also the same. So the only way to make the difference is to add some additional dummy integer, and that is how we can distinguish between these two. So the pre-decrement is the normal one, and the post-decrement we consider addition of the dummy integer. So in other words, if you use and in both the cases we have got the flexibility of writing a member method or in terms of friend function. Okay. Yeah. So let us look into the code. So is the code visible?
Yes, sir.
So can you see this? So more or less the same thing. So this is the pre-increment. So in the pre-increment, what it seems, so what kind of implementation we are considering here for the pre-increment? Member function or friend function?
Member function.
Member function, because there is no friend keyword here. So because it's a member function, it will be invoked by the object which you would like to pre-increment, and it will accept void, no arguments as an input. Okay, so this is the case, and I have chosen to implement the post increment using the friend option. Is that fun? Is that clear? So the pre-increment I have considered the member function. For the post increment I have considered the friend function option. So I have tagged it as a friend, and this is the operator function which is still remaining the same name, but in this case I have to pass explicitly the object because the friend function and the so this is a dummy integer. Okay, so if we come down to the implementation, so this is a pre-decrement. So in the pre-decrement means so if I write say a I mean minus minus a, that means the a will be within that within that function call. A will be decremented, both the imaginary and real part will be decremented, and it will be returned, the object itself will be returned. So that's why it is real minus minus, imaginary minus minus. That means so you can consider it to be this pointer pointing to imaginary, this pointing to real, and then return this. Because so this is one case where I indeed require the reference to I mean the mentioning of the this pointer, because the object itself after getting modified wants to return its reference. So because it is returning reference, it is asterisk this, so that means it is object, and this means it is returning its reference. Is that part clear? The object which has invoked this member method after getting modified, the modified object is returned, so that this is pre-increment, pre-decrement. So you modify and then you assign it to some other variable. Hope this is fine, right? So this one. So what about the post decrement? So this is the implementation of the friend function. So that's why there is no mention of this class scope. We just write the function directly. And what it means, before you modify, so which object you would like to modify? You would like to modify this object C, whose reference we have passed to this friend. Now before you modify the real and imaginary part of the object, you basically store the object state in some static local object T, right? So that it is retained, and that will be after this execution of this function, the original state, the previous state of the object C should be returned, but by the time C should modify itself also. So when you are returning basically T, that is the previous state of the object, but the change that we made in the object C will be retained because you have passed the reference, and anything that would make any change the original object C after the operation will be changed. So in this case, if you assign C assigned B minus minus, that means the previous value of B will be assigned to C, but at the same time B itself will be decremented. Is that part okay? Any question? Hello?
No, sir.
Okay, so let us get back to the overloading case. So do you think that we have got an entire list of operators in C, C++, any programming language provides a predefined set of operators which it deals with for predefined data types or classes. Now, do you think that all the operators that is available in C++ is overloadable?
No, sir.
It is not. I mean, there are some restrictions and there are reasons for that. So that is the case. And there are some operators which are not say which you cannot overload using say friend function or this. So there are some restrictions on that, and there are some operators which you can overload by both means, both the options. So this is the list to be, the points to be noted. Okay, so this is except existing operators, no new operators like these can be created. So when you are talking about operator overloading, you cannot as a programmer create new symbols as new operators and then you try to overload it. Okay, overloading means somebody is already existing and you are trying to assign some new responsibilities to that person. That's all. So operators that can be overloaded is this list, right? So these are some of the representative list of operators which can be overloaded, and you can see that it has got the arithmetic operations operators, then the bitwise operators, then the logical operators, and the relational operators, you see. And what are these meant for, these operators? What is this? What is this operator originally meant for?
Function operator.
Hmm?
Function operator.
A bit louder.
Function operator.
Function operator, or you can say typecast operator, something. And what is this one? Subscript operator, array subscript, right? And what is this? So it's a dereferencing or this kind of operator. So, and what is this new and delete? This also we know that these are operators, right? Although they do not seem appear to be as symbols, but they look like keywords, but these are operators that we already found in our last in our previous classes. Okay, unlike the malloc and calloc, these are operators, and because these are operators, so they are also they can also be overloaded, and we'll see that how and why this new and delete, why and when this new delete need to be overloaded. Okay, so these are kind of special operators. Say this said, you can say these are special operators, but So these are special operators, but these are more or less the common ones that we all use. But the operators which cannot be overloaded is size of. Size of is also operator. Do you know that? Size of operator. And then the member access through pointer to member. So these operators cannot be overloaded. And in this case, there are reasons for this. So difficult to infer if it is for object reference or overloading. Okay, so then the ternary operation, conditional operator also cannot be overloaded. And the scope resolution operator cannot also be overloaded. So I've mentioned the reasons for this. You can go through it. This will be our last operator overloading class, so I'm skipping it. The details. The arity and the precedence and the associativity of the operators cannot be changed. What is arity? Binary, unary, and this. So operator which is defined as a unary operator, you cannot make it. So originally it is unary, you cannot make it binary. Fortunately, this plus and minus, these are both unary and binary, so that is fine. But if there is some operator which is originally a unary operator, you cannot make it binary. Precedence also. So if the addition, deletion, addition, subtraction, they come as a lower precedence compared to say subtraction, multiplication, division, and all this. So that precedence cannot be changed. So if you even if you overload and if you call multiple overloaded operators in a single say statement, so the original precedence still holds in which order they will be executed. Associativity, we know that when we write a large expression involving operators and operands, so then the associativity, so sometimes if you have got three addition so say 2 plus 3 plus 5 plus 6 in the same line, so in which order they will be evaluated? Will it be from left to right or right to left? So there are some predefined rules for each set of operators, and that also cannot be changed. And operators like this ANDing and ORing, when overloaded, loses their special properties, that is short circuit evaluation and sequencing. Better to avoid overloading them. So it is better not to overload this comma and these operators. Okay, so these are some points to note regarding overloadable operators. So as we mentioned that most of the commonly used operators can be overloaded, and these are the special operators. Special in the sense they require some so mostly they are not used, but sometimes they are really useful, and we'll take some of these examples of these operator overloading next. Okay, so in the next few slides we'll be talking about overloading these operators. What are these operators?
Insertion operator and
Insertion
extraction.
operator. So the thing is, if I would like to write say C out this insertion or extraction, then ABC, where ABC are say complex objects. So we would like to implement the cascaded output or cascaded input in case of user defined objects. Okay, so by overloading these operators in that class complex or class matrix. And also we'll look something related to new and delete overloading. Okay, so in the part 2 we'll be talking about this. So let's switch to that one. So any question till this point? Okay, now overloading of this these two operators. So let us focus on this one. And we have say for example the complex class. How many of you have overloaded this in your codes? Overloaded either of these two operators in a cascaded fashion? Is there anybody who have done that earlier?
Yes, sir.
Okay. Anybody else? How many?
Yes, sir.
Okay, there are a few who have tried this. Good. So here, the rest of the students will know it. So let us assume that we have got complex ABC, and we know that the construction, everything is done, is taken care of, and we have got the complex display. Okay, so the way we are trying to display till now, say x plus iy or x minus iy, so in that format as I found. So I know that we can display it using complex display, then b dot complex display, c dot complex display, like this. So this way it works. We have found that, and I think the codes also I have shared, or I'll share it. Now I would like to write, instead of doing this, I would like to write, what would be my preference if I would like to overload this one? C out, like this, or C out B, or C out C. So instead of this, I would like to write this one. So now tell me that what the translation will be here. What will be the translation when you write this one? What is this and what is this? These two are
Objects.
what is this? This is an operator, right, in between. So what do you expect the translation would be look like? Will look like?
Cout dot operator.
So it is C out dot operator,
Left shift.
then
A.
A. Is that fine? So now tell me which particular class you would like to insert this. So it is it looks like a member function. Do you all agree with this?
Yes, sir.
It's like a member function. So in which particular class the member function? So these two are objects, right? So which class this cout belongs to?
O stream.
Hmm?
O stream.
Belongs to O stream class. And which this belongs to? A. It belongs to complex class, right? So now I have got this member method to be inserted, operator minus, operator this one. So which class should I include this as a member?
O stream.
O-stream class. Is there anybody who has ever worked or have the, you know, you have the fortune to see, I mean, to see the details of the O-stream class or I-stream class? Are you lucky enough to see that? Because then I have to write the code and push the code there, right? And then again recompile it. So have you ever seen that O-stream class or I-stream class? You know that it is there. It's a compiled version. The object code is there. But did you ever see the source code of that, and have you ever tried to modify it? Is my question clear? Because cout.this means you have to insert it in the class corresponding to cout. That means in the O-stream class. Can you modify it there? Hello?
So, haven't tried, sir.
No, you cannot do that because the O-stream and I-stream classes are not available. The source codes are not available. You only deal with the object codes. So is this possible?
No, sir.
Are you getting my point? Is this option possible? So this is not possible because we can't say modify or add something in O-stream class. So now then this kind of translation will not work. So what is alternative translation that you can try?
Friend function.
Operator and then pass C out and A.
Will this work? The second option. So now, what is this? Is this a member function?
No, sir.
This is a friend function, right? So what is this? This is a friend function. Now the friend function also need to be, so whose friend you should declare it as? Again, there are two classes.
In complex.
In complex class, do you need to add it as a friend of the OStream class also? Is it mandatory? Is it required?
No, sir.
Because you are just using an instance of OStream class, that is cout, but you are not probably attempting to do or access the private members if there is any in that particular class OStream, right? Do you agree?
Yes, sir.
So just having that this particular function implemented here in the complex class is enough. So now can you tell me the prototype of this, what I need to write here? Tell me quickly. So this is the name of the function. It should be a friend. So it is, and what it should return. So now I am calling cout this, cout this. So this is void. Okay. And it should be a friend. Now how many arguments it will be there? Please answer fast. So there are two arguments. What will be the type of the arguments here?
OStream and const complex by reference.
So let it be X. And the second one is complex. Say it is say B. Right. So now within this, what should I write? What is my intention? Is to basically copy this code. The logic of the code will be the same, right? Hello?
Yes, sir.
Yes, sir.
So the only thing is wherever we have written cout, say this, what I am referring, actually B is, the object B is real part, and say cout, the object B is imaginary part. Is that fine? So instead of writing here cout, what I could have written here? So who is the what is the new name given to cout now within this method?
X.
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 So can I write here? Can I write here X instead of cout?
Yes, sir.
Because it's just a new name given to that cout. So the original cout is still there. So I can write either cout or X. Doesn't really matter. Using this, right? Is that part fine? So the rest of the logic is the same. So once I do this, that means this particular operator function or this particular operator now still it starts working with any complex objects also. Is that part fine?
Yes, sir.
Now can you tell me one small modifications if I would like to write cout A, then B, then C in a single line. So instead of writing it like this separately, I would like to write it in a single line, in a single statement like this. Then what modifications should I make? So this cout,
Return by reference.
cout originally in the previous case it was returning what? It was returning void. So if it returns void, so nothing will be left here, right? So nobody will be there to go for another invocation of this followed by this like that. In a sequence it will not be done if it is void, returning void. So what after calling cout this operator A, what if I require in place of this the same object. Which object do I require?
C out.
See out.
Same object C out, right? So C out do I require here. If I can return the C out, the same C out here, the C out can still work, that C out, this operator B, which again in turn will be returning then C out, which we will be calling like this. So to enable that, instead of returning void, what should I return?
O stream by reference.
Stream reference.
O stream reference, right? And what should I write here? Return
X.
X is just a reference to that, so return X, that's all. Now will X, so will there be a issue of like live whether the X is alive or not? Because C out remains always alive, right? C out has been declared by the compiler and it remains. So it's not a local object, so it's just a local reference that you create for that C out, but the C out exists forever, right? So we just used a local reference which will be off, but I'm anyway returning the reference of that. I mean returning the object itself. Are you getting the point? Is that okay?
Yes, sir.
So that means if I have this particular syntax, I mean this particular prototype of returning ostream ampersand and this thing, so I can have a more generalized call, a cascade. So this is what we call as cascading. Cascade means it's a stream of, I mean it's a sequence of calls. Okay, so cascade is also used in the English vocabulary. Also we know the use of cascade. So cascaded waterfall, so one after the other, so it's continuous flow. So it's also a continuous sequence of calls. That is why we call it the cascaded calls. And then this can be nicely used mostly in case of operator overloading, which makes it much compact and more readable. So this is what the actual code looks like. As you can see here, we have the C out this. So instead of this line number 88, I would like to have line number 90 replaced by that. So I can have both of them. So this is the original code of display complex, and this is the code corresponding to the overloaded operator. And as you can see that it is exactly the same. Okay. So the only thing is, instead of writing here C out, I prefer to write here X. But again, I mean, I could have written that C out also without any problem, because C out has got a global scope. So that is the only change. You see the use of X instead of C outs. And additionally, I am returning X because I am passing here poststream this. So here I have declared the prototype as a friend. So this becomes a friend of complex class, because even though this function, friend function, is not a friend of the ostream class, it really, I really don't care, because through this function I'm not trying to touch or access any of the private members of ostream class. So this is enough for the implementation. Is that fine?
Yes, sir.
Okay. So I think we can have this. So this is the code. You can see that. Okay, so what's the name of this? Demo complex unary. Can you see that it displays in both ways? So here it displays using the by calling the display complex twice for displaying C and B, and here we have done the same by using this cascaded operator overloading. So this way also it works, and by using the cascading also this works. Okay. Okay, so now I would like to quickly get back to the some of the special operators. Now this thing will be a bit more, I would say, non-trivial, and so I would request you to try to listen to the points that I discuss. And in fact, in my last year's lectures, there are almost like 2 hours lectures on this. So I'd like to make it a more compact presentation of this, and I would share those videos. So if you would like to have some more insights, you can get through the details of it. Okay, regarding the special overloading of new and delete, and then with a case study of linked list with avail list and all. Okay, so let's look into the some of the basic things. So overloading a subscript operator, what can be the interpretation? So in case of a linked list, you see, if I've got a linked list SLL, say L1, so I know that there are many operations possible. Now, if I would like to access, say, the 4th element, so if there is a linked list like this, say if I would like to access the 3rd element or the 4th element, what do? I will have to traverse through this and I have to access it. So if I can interpret that this to be the 0th element, this to be the 1th element, or this to be the 2th element, like this in a linked list also, similar to that array. So can I write L1 L1.2, so L12 like this, L12, and assign it to an integer x. So what is the interpretation? This means I would like to access the info part of this node, obviously by traversing through the linked list, but the details will be handled by the member, or maybe the operator, overloaded operator function, this one. Okay, so I can suitably create the say the prototype of this, and the implementation is basically a traversal right from the head, and you have a counter, and once you encounter that information of that specific node, you just return it. That's all. So I think you can do this, right? Hello?
Yes, sir.
So this is just one idea. So now another interesting operator is the assignment operator. So this is the assignment operator that you all know, right? So this is the assignment operator, and this is the equality, checking the equality operator. So I am talking about the assignment operator. So when I write complex C1, C2, and I would like to write say C1 assign C2. So what does it mean?
C2 is assigned to C1.
So this is C2 is assigned to C1. So in my complex class, if I just write, so I have written everything, but I have not. So what do you expect? What will be the translation here? Now tell me quickly. Please don't take so much of time.
C1 dot operator
C1 dot
equal
operator,
C2.
because in true sense, if I would like to take so much of time, it will take another 2.5 hours time, and that is not possible. So here, so I would like to give the brief idea. So you expect an operator member function like this, right? To be written here. So if you have not included this here, do you think that it would have worked? So if I write C1 assigned C2 or C2 assigned C1 without having such a member function or a friend function to be included in the complex class, do you think it will work?
Yes, sir.
Other students, what do you think? We have got two user defined objects, right? C1, C2, which belongs to user defined class complex. And I have not, what I make a statement, I have not written any overloaded function, any operator function corresponding to the assignment operator, neither in form of friend function nor in form of member function. Do you think in that case it will work?
Yes, sir.
The rest of the class, do you think we expect it to work? What is your intuition? What your intuition says? If I just like write instead of here, if I write plus, will it work without adding operator function?
No,
No,
sir.
sir.
Minus, it will not work. But if I write this assignment, will it work?
Yes, sir.
Got it? That is again something you can say that it is working with the default overloaded copy. So this is probably the only operator which, without even overloading, writing overloading method, it works, because it says that okay, you probably, this is very simple, so I can do it on your behalf, and it's up to you if you are accepting it or not. So what it says that there are two objects, right? So this is say object A, object C1, and this is object C2 that it wants to create. So it says that all the members are there. So you are basically copying all these the contents of these members here, right? That is what copying means. So here the compiler provides a free option that implements shallow or bitwise copying. So can you recall the side effects of shallow copying or bitwise copying? Sometimes back we have talked about in details. Can you recall that? Where we face the problem accepting something that free.
Modification of B will
Yes, sir.
What is that?
change the values.
Hmm?
Modification of B will also change the original constraints.
Yeah, so what was that? While constructing, right? While constructing an object from another object. So
Yes, sir.
it was like say maybe complex C1 from C2. It is something like this. Or complex C1 equals to C2. So when you are constructing C1, you are initializing it from C2. So it's basically the problem of default copy constructor. Can you recall that? Can you recall the side effect that got created? Because
Yes,
if
sir.
there was a pointer member, in this case probably it doesn't matter. If you go for bitwise copying, you accept it, it's fine. But if there is a pointer member here, then what happens? Say this pointer member is there, then what happens in due course of time when you actually do this? Say this is B. Can you see the B here? So when it copies B directly, so what is this? This is a B. Okay, so this is A, this is B. Now I am copying B to A. Is the case. After the copying, what happens? Both B and A points to the same location. And you know the result, because when the control comes out of it, it will anyway destroy which one? Which object? Object B, right? Hello?
Yes, sir.
And as a result of it, so object A, the pointer member of object A will be dangling. It will be pointing to some garbage. Okay, so here B goes out of the scope and the destructor of B goes out of the scope, and the destructor is getting called, so that gets dangling. Because you see, so what I mean is, so it's no longer, so it's basically a garbage. It is not whitened. So this is, so things are there, 4.5 is written there, but you are dealing with garbages. You don't know, maybe in the next time the compiler has taken out that location and it has allocated to somebody else. So what's so how to avoid this? So probably in this case of complex class, you don't really need to worry about it. But for any classes which is having a pointer member, or in which in any of its data members, it has got a pointer member, like the linked list class or like that. So there you probably have to explicitly overload the assignment operator by writing something like this. Is that fine?
Yes, sir.
And you actually make the allocation explicit to the to that, and then carry on the copying of the data and all this. Okay, and if I would like to write something like this, a, b, then c, then d, what do I need to do? So this is again a kind of cascading of calls to this operator function. So instead of, so how to implement this, what change you need to make?
Return a reference to complex.
So you have to basically write complex this, and you have to write return. Which one you return? Asterisk this. Is that fine? Or maybe the C also, you can return any of them. Any question? Hello?
No, sir.
I'm moving a bit fast, but I think you can all understand what I mean. So if I do this, then it will be actually, so even if it gets destroyed, B gets destroyed, but A actually retains with a different location the copied contents. So there is no harm. Okay, so it says that the compiler provides a free one if it is not explicitly overloaded. Free one considers a shallow copying, and anything that you deal with free offers, you are always subjected to future problems. So by dynamic allocation, if dynamic allocation is used in the constructor or the class as a pointer or reference member, this overloading of this is essential. This operator is essential to to actually implement deep copying. Okay, in other words, if a constructor needs to be defined, a constructor, if copy constructors need to be defined, overloading of this is essential. So both should go hand by hand. And then deep copying and shallow copying, I think these things you can read of your own. So let us come to the operator, the overloading new and delete operator. Okay, so when I write complex, say C1, and then complex asterisk P, and then P equals to new complex, what does it actually mean, this statement?
In a complex object is allocated on the heap that is pointing to
So
it.
if I do this, what do you think? So there are two tasks that is done, T1, T2. So what is the task one? Task one is allocation of the space, right? Allocation of objects space. This is the first thing. Where from the allocation of space takes place?
Heap.
From the heap. Followed by, what it is followed by?
Assignment.
No, not assignment. There is something gets invoked. What is that? Hmm? What do we invoke? I think we have already illustrated this. So you are trying to create dynamically a complex object. So the constructor corresponding to that class will be triggered according to the pattern of allocation. Can you recall? Hello? Do you agree with this? There are two things. One is the heap allocation from the heap, Dynamic allocation from the heap followed by the construction. Construction means those initialization steps and all this that takes place. So a new and delete operator can also be overloaded. So the thing is, when you do this, you can make sure that during allocation something else take place. Okay, and during deallocation also what happens, it is just the reverse. During deallocation the destructor gets invoked and then the actual physical deallocation takes place. So now there are certain uses of this new and delete operator, and so the question is, can we make something extra during the delete operation and make some provision so that the local pointer by we'll talk about some of the cases where it is useful. So the thing is, when you write this, as I mentioned, so dynamic memory allocation calling overloaded operator new, and then this is a constructor gets executed. So when the delete p is delete p, we call delete p, there are two things. It is first the destructor is called, and secondly the object storage is deallocated. So it's just a reverse of the calling to new. So there are possible cases when we probably would be interested to overload new and delete operator. So these are some of the cases. One case is okay, it's almost time anyway. So one case is, say, whenever you are trying to deallocate some space, say maybe in the contents of a array, you are deallocating, which you have dynamically allocated. So so if you just delete it, it's fine. It will be deallocated from, and the memory manager knows that, okay, you have made it free. But maybe whenever next time it is allocated to some other code, right, some other process maybe, which is not belonging to you, that person, after it gets allocation, it will read that particular locations. So there is a memory leakage, and through that you basically your information, prior information which you have deleted, you thought that I have deleted, but that information is available for access to others. Are you getting my point, what I mean? So it's like I have checked out my hotel room, but I have not so I've written something in the wall and I've checked out the room. So I have not undone the things that I have done. So the next person, when he comes, if maybe your ATM password you have written so that you do not forget. So he just gets it and he misuses it. So the thing is, deallocation, when it goes for delete, it's like because that is not actually done. So the garbage space, I would probably like to you know release that, or I would like to rewrite it to be -1 +1 like that. So that may be one case. Another case, in case of linked list, uh, or maybe while we are trying to deallocate from the heap or allocate from the heap data, the heap segment. So if you allocate and deallocate frequently, quite frequently, what we will find is that the actual heap is basically fragmented. Okay, so you have got this much of free space, this much of free space, this much of free space, like that, but these are all occupied. So now if you require some space, a contiguous chunk of this much of space, that is as you can see here, this is not continuously available, but it is available if I add this part, this part, this part, this is available. So maybe in the heap also we can think of running some defragmentation code, which each and every time or after a while, before you ask new, it will say or maybe after it has deleted something.
Hello, sir.
Yes.
Sir, we have class from 10.
Yeah, I understand. Okay, so let me stop it now and I'll share you the video. You can follow the video. Just one nice thing that I'd like to, okay, it's already time, so better I skip it. So this is a code which actually tries to create a linked list and allocation deallocation of linked list using avail list, okay, by overloading delete and new. And I have actually physically tested the time taken by while I create 2 to the power 10 number of nodes here, okay, here like this, and it has been found that by modifying that new and delete operators, overloading, it has got a significant reduction in the physical time. Okay, so the code really gets a speed up. Okay, so I think I'll share the videos, you go through it, and if you have got any queries, we can discuss it in the next class, and hopefully the next class will be in the offline mode, and this will be the probably the last class in a combined form. Okay, so then after that, as I've decided, I'll take the section X and Z, and Deepanita will take the section Y. So accordingly we'll proceed. Okay, thank you. Happy Holi, and welcome you in the campus. See you in the campus.
Thank you, sir.
Okay.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.